Good morning, everybody, and welcome to Rockport, Massachusetts on this fine fall day where the skies outside of the studio are blue, the ocean is pure and crisp with waves gently lapping on the rocks along the pure, cold, crisp rocks on the shoreline with a cackle, caw, and craw of the seagulls on the nearby rooftops of the old fishing shacks, creating a symphony to behold. My name is James Atkinson, and I am a scientist, an engineer, and a nerd who has been hunting human informants, spies, snitches, and weasels for close to 50 years, and I am a master at it. I'm also an expert in various disciplines in the forensic sciences, to include computer forensics, cell phone forensics, a bunch of other forensics, and I am very skilled in the processing, collecting, identifying, and detecting fraud in forensics dealing with bodily substances, and have actually been able to disprove government experts who confected DNA results. I was able to prove that they were a complete fictional, and officers lost their jobs. Welcome to our broadcast today, where we pretty much talk about hunting spies, neutralizing snitches, stopping invasion of privacy, and shutting down espionage, no matter who the spy or snitch may be. Now today, we're going to be talking about exploiting the horseless carriage, or in other words, exploiting motor vehicles. This would be typically passenger motor vehicles, and a topic this series will fall under the foreign collection methods, indicators, and countermeasures, because we're going to tell you not just how your local police department do this and how parents do this to their children, but we're going to talk about how foreign intelligence agencies do it and what to look for. My name is James M. Atkinson. My website is www.tscm.com. That contains approximately 65,000 pages of information about TSCM, and it's all free. My email address is jmatk@tscm.com, and my LinkedIn profile is on the bottom of the page. I've testified before Congress multiple times. I've worked for Fortune 500 clients dozens of times. I am a total hardcore nerd and geek, but I have a good business presence, and I've worked for congressmen on both sides of the aisle and in both houses. I am a defense contractor, and like I said, I am the best when it comes to hunting spies. There is no spy hunter better than me in this entire country, and that is a humble brag. That's about as humble as I can get it. The entire contents of this video is completely unclassified. It does have some proprietary methods, but they are my proprietary methods, and I feel that these should be shared with the public. Just a little safety warning. Vehicle-oriented bug sweeps are all inherently dangerous, and there is a risk, a very high risk actually, that you could be injured or you could die if you try to do a bug sweep on your vehicle and you are not an expert on how to do it. So, high risk of injury or death, so don't try to do it on your own. Now, bug sweeps on automobiles. This can be an automobile, it can be a pickup truck, it can be an SUV, it can be a commercial truck, it can be a bus, it can be a motorhome, it could be a motorcycle. These all require highly specialized locations where the bug sweeps can be done, and well, in an emergency, a bug sweep expert can do a pretty good bug detection just by you parking your car on a tarp at a seedy hotel and then working it over for a few hours. It is best that it be done in a purpose-built inspection facility where several days can be taken, very often several weeks are taken to thoroughly inspect the inside of the vehicle. This is not something that some random guy who goes out, spends $900 on a magic box and takes 2 days of training should be involved in. You're getting cheated if you engage that guy. You want to engage somebody who can bring a couple $100,000 of equipment and who can take as much time as it needs to do a bug sweep on your vehicle. Now, in this presentation, we're going to be discussing bug sweeps on vehicles. And surprisingly, I'm going to discuss bugs on Amish buggies. And I'm also going to discuss bugs in Italian sports cars and everything between. Now, this video is not going to talk about lawnmowers, boats, farm tractors, aircraft, or hot air balloons. I have done bug sweeps on lawnmowers, boats, farm tractors, aircraft, but not yet on hot air balloons, and those are definitely something that we need to leave for a different presentation. Now, let's look at some uncomfortable realities. In modern American passenger vehicles, post 2007, these would be your sedans, coupes, minivans, passenger trucks, etc., include 10 to 15% of the value of the vehicle in GPS systems.
This is a reminder. Prepare for video.
GPS systems, video cameras, radar systems, a wide array of microphones, integrated cell phones, a hard drive with maps, data modems, which cause your car to come pre-bugged from the factory. Now, this changes approximately 10 years later to 10 to 15% of your car's value. So if you go spend $100,000 on your car, $25,000 of it is to be paid for cameras and microphones and monitors and automatic tire pressure sensors. And this all adds up. This was quite an interesting way to increase the MSRP of vehicles, which they started back in 2004 when the first designs came up. So with modern, post-2007 American market passenger vehicles, you're spending 15 to 25%, which is quite a stout amount of new electronics that are not needed to make the car run. Now, this makes a car built in 2007 versus 2017. The 2017 has 400 times more invasiveness than the car in 2007. So if we take the exact same model of car, let's say a Chrysler 300 from 2007, and we get it with the audio, the video, the screens, the backup, and all the gadgets that come with that. And then we take the same model, but for 2017, and we get it appointed in the same way. If we then take apart both cars, we will find in a 2017, there are 400 times more invasive over that of the period of just 10 years ago. Your newer cars all come extensively pre-bugged, and it does not matter who the manufacturer is, because they want to sell you 25% of your vehicle in the form of entertainment systems, radar systems, safety systems, automatic brake systems, navigation systems, multiple types of radios and tracking. You don't have any privacy in your car. It's just you're buying a car that you did not know is pre-bugged. Now you can hire a company like us, and we will go through that car and take it apart and remove all the little bugging things, and you'll have privacy in your car again. But if you spend $40,000 on your car, and then you bring it to us to have us remove all the bugs, that may very well cost you $80,000. But at least you'll have a car that doesn't have built-in bugs. Now when we do a bug sweep on a car, first thing that we're looking for is we look at the threat or risk period. So, is something a threat or is it a risk? Is it something they can live with, or is it something that's going to destroy the company? So we look for tracking devices, we look for video devices, and these aren't just dash cams that look out to see what traffic is doing. We're also looking for video cameras hidden in the A-pillars or in the headliners, which are very popular to high code video cameras. We're looking for hidden microphones that go with the audio devices. We're also looking for radar or LiDAR that's built in the vehicle, which can be recording speeds or taking a sort of picture of everything that goes on. We're also looking for telemetry devices. This is very common in a commercial device. A lot of owners of commercial trucking lines, they put telemetry devices in. Give example, Amazon puts a telemetry box in all of their vehicles, and that interfaces into the engines so they can see how fast the vehicle's going, how fast the engine's being revved, did it get oil changed, and so forth. Then there's exploitable hardware, and this is the typically bus access points to get you into the automobile digital network. There's a wide area network that operates in your car, which can be, for example, in some cars you take the rear taillight out and there's a network connection, and you can connect into everything inside the car and never open the doors. And you can read all kinds of data off the video recorders, and what's one of the ways actually that the FBI does bug a car is they take the rear lens off, they interface a telemetry module in, and then they put the tail light back in place. Then they need only walk near the vehicle, and then there's a non-contact link from the vehicle, and everything that vehicle's done, everything that's said in that vehicle, and every place that all the driving a vehicle does is all downloaded by the FBI without a court order, without a warrant, and they do it, and they know that they're not going to get caught, and if they do get caught, then they'll backdate a warrant to cover it up. But it's widespread and happens way more often than people are aware of. Then we also look for other hazards and other risks, which can be quite extensive. Now, let's give you a little reality check. You are more at risk of eavesdropping in your own car or truck than you are in your own home, office, or bedroom. This is because people practice certain assumptions that their car is their little oasis in all the chaos. So they do things, say things, discuss things in their automobiles that they would not discuss in other venues because they have the illusion of privacy. So if nothing else, let me assure you, you do not have privacy in your car, and you shouldn't be doing anything in your car that you shouldn't be doing elsewhere. Hopefully, you only do your private business in your home or office and behind closed doors and lowered shades, or maybe not. So when we get ready to do a bug sweep, this is generally how our profession does this. Granite Island Group does it a bit differently in a very big scale, but these are the basics. Our first 7 things to do. First, you got to make a plan. You got to get the vehicle to a location where it can be inspected. You have to be careful not to deviate from that plan so that everybody shows up. I'll give you an example. I may tell a client that they're in, let's say, Concord, New Hampshire. So I will have them bring their car to Concord, New Hampshire, and then I will hire a tow truck to tow it to a seedy no-tell hotel down some dirt road about 30 miles away, where I've rented out 3 rooms. I will show up with a van and somebody will show up with a tow truck. Then as I go through and I document what I'm doing, I put it in a laboratory notebook. If you've seen me lecture live, or you've seen some of my other videos, you know how I document in notebooks prolifically. I also have to work from shop manuals, so I will have the detailed shop manual, both the body shop, the driveline shop, the electrical shop manuals. There will not be a thing that the dealership has that I don't have. These are very expensive, and these are built in the price of doing a vehicle sweeps. Granite Island Group does, however, purchase each year tens of thousands of dollars of shop manuals, shop software that we use in the barns where we bring vehicles. If we bring them out in the field and we do them out in the field, but if we can bring them into one of our facilities, then we have full high-tech diagnostics labs there. There are some essential tools you're going to need if you're laying on a tarp at a truck stop or at a hotel doing a bug sweep. There are some essential tools such as flashlights and mirrors, RF sensors, spectrum analyzers, which you're going to need. You're going to need a place to work. If it's indoors, you're going to need about 20,000 square feet, and I'd say about 600 pounds of tools. If you've got a larger area, so if you happen to use one of the Granite Island Group labs, you may be dealing with a 40 to 50,000 square foot garage where we store our vehicles, and where we have a double shielded room that we use to take vehicles apart while inspecting them for bugs, so that the bugs can't transmit outside the room. There also has to be a great knowledge of the threats, and that comes down to what is out there that's designed for eavesdropping, what is out there that is designed for tracking, who uses it, when do they use it, why do they use it, and we'll get into that a little bit further into this presentation. Now, I regard these as the most essential resources, and you get these before the client engages you. So, for example, next week, I am bringing in a shipment of Chrysler and GM shop manuals, CDs, and all the various trim and power line. It will be probably 4 library shelves of just service manuals in hard copy form, and then also in a digital form. I will bring in also laboratory notebooks to have those on hand for engagements, a huge library of shop manuals which are constantly updated, because I don't want to have to wait to do a client's vehicle because we don't have the book. Now, I avoid Chilton style and multi-year books, and I get the I take the VIN numbers and I get to make the model, the year, and the trim. So I have everything in the books. In some cases, there'll be power line variations, so I'll get the books for those. And then I always get the detailed electrical diagrams, which is absolutely critical. Now, the detailed electrical diagrams can sometimes be virtually impossible to obtain, but I have a way to legally obtain them. I just can't share them because they don't want the dealerships to have those. But I have to see everything right down to the component level. And when necessary, when I get a electronic diagram and it's down to the module level, then I buy a module and I take it apart and I document what's going on inside that part, and I reverse engineer my schematic for what the factory's not giving to me. But I've since learned interesting ways to get the component level. Doing this is very expensive, but it's vital, and it's a cost of doing business. Also, this is not the owner's manual. However, I usually will also buy the owner's manual just so I can understand which seats move, which buttons move the seats, which ones turn the stereo on. And I will actually go through and read the entire owner's manual before I'll touch the vehicle, so I know how to lock it and unlock it. Now, essential tools that you'll need. You're going to need lots of flashlights. Now, this assumes that you're going out in the field and doing this at a truck stop or behind a restaurant or a hotel or something like that. You're going to need a lot of flashlights and short lanterns because you need to light up the whole underside of that vehicle. You need compact mirror systems. You're going to need something that you can use to hold your cell phone so that when you see something hinky, you can take a photograph. You're going to need a lot of thin nitrile gloves because this keeps the grease from getting spread around the car. You're going to need protective tarps or covers for the seats. My preference is a clean painter's tarp, a white one, and that keeps every blemish off the seats. And then for a ground tarp, I take 2 painter's tarps, and between them I put thin high density foam that I roll up with the tarp. And then if it's going to be cold out, which often it is, then warm weather gear, but that's strictly optional. This page is only for people who do TSCM for a living. If you don't do TSCM for a living, there is a high probability that you're going to get hurt or you're going to collect information that is in error, which will involve you spending $40,000 on or more of test equipment and not having a single idea what any of the data means. So the data needs to be collected by somebody skilled in our craft. The data needs to be interpreted by somebody in our craft. So what you see here is what we call critical test equipment for doing a bug sweep on an automobile. The first piece of equipment is called a broadband signal detector with alarms. There is one channel for each mobile uplink. There are sharp bandpass filters for each of these uplink channels, and then there is a matching antenna that is precisely tuned to that frequency. Most of the United States requires 24 or more filters, and the output of these filters are collected onto multi-channel chart recorders. There are some areas of the United States that we would use 36 filters. There's others where we would use 48. But each of those filters has an alarm on it, and The output of those filters goes to chart recorders so that the vehicle can be driven to see if we can activate and stimulate a tracker of some sort coming on the airwaves and reporting position data back to the eavesdropper or to the spy. So that's the first weapon that's used, or test equipment. The second test equipment is similar to the first, but this is typically 8 spectrum analyzers. One spectrum analyzer is configured as a cell phone service monitor. The others are looking at specific bands that are used for mobile uplinks, and then those copy also to chart recorders so that data is kept very fresh. We also utilize, when the spectrum analyzer detects a signal, then there's a handoff to a computer-controlled software-defined radio, which parks on the suspected signal and records it in a digital format on chart recorders or also onto computers. We also have to use amplifiers, filters, and antennas because we have to connect this equipment directly into the DC network that exists inside the vehicle. We also have to use high-performance digital voltmeters and high-performance digital handheld spectrum analyzers. 9 times out of 10, we are also going to use handheld spectrum analyzers. We'll also need PCM tools. These are the generic ones you buy at the your local garage. Then we also buy the ones that are specialty from Mac Tools and from Snap-off Tools and other companies. And then we buy the ones that only the dealerships normally can get a hold of because we want all of that in our vans. We will also have a special Bluetooth dongle which picks up any Bluetooth activity at all in the vehicle, and a modified 802.11 interception system to pick up any AirTags or any type of Wi-Fi devices. And this is the critical test equipment. Now, the facility requirements for doing bug sweeps on automobiles is a little bit tricky due to a variety of immediate needs. Sometimes a hotel parking lot is where you do the bug sweep. You lay down tarps, you park the car on the tarps, and then you move the tarps around. Or you use the garage at the customer's premises. If they have a large enough premises, you again park the car on a tarp. I use highly reflective tarps so that I can see under the vehicle better, and I of course bring lights so I can light up everything. I do prefer to work in a purpose-built garage, a repair garage, where we put the vehicle up on lifts and stands and not have to slid around underneath it, but we have to work with what we're given. A neutral location or a garage that doesn't lead to a TSCM activity can be very handy at times. Examples is dealerships. You can rent their garage after hours, usually, and rent half a dozen of their people to help you take the car apart and give you access to everything you need access, and then they have the car completely put back together before they open for business the next day, and there's no evidence the vehicle was ever taken apart, even though 6 hours ago the seats were out, the dash was out, the sidewalls were taken out, and the vehicle was essentially stripped down. Now, ideally, you want to use a specialty garage. And a specialty garage is a garage that is designed just to do bug sweeps. that consists of two shielded rooms. So the vehicle is moved from one room and then into another room. And those two rooms ensure that no radio signal or cell phone signal or tracking signal can leave the room. And then a conduit is set up so that when it's trying to make activities outside the room, those are captured on specialized test equipment, and that is what's called a double shielded room. There's also specialty garages, which will be a full scope inspection garage, which will also contain a shielded room, but the full scope inspection is not just done in the shielded room. And to use the specialty garages, there has to be a shielded transport to the specialty garage. And what this is a truck that will place a container down on street level. Your car will be driven into the container and chained down in the container. Then the garage will be the transport box will be sealed, and once it's sealed, that car will disappear. It will not be able to access cell phone networks. It will not. It'll just be disappeared. If somebody has a GPS tracker on it, that GPS tracker just went blind right at the moment it was picked up. That cargo container is then hoisted up onto the back of a transport truck. It is then brought to one of our regional specialty garages. The container is unloaded and it's pushed into our shielded room, where it's removed from the container and it stays in that shielded room until the entire inspection is complete. It will be then placed back in the shielded container, put back on a transport carrier, and taken to the client's garage, and then unloaded and put back into their custody, with no evidence that it had been taken apart in 2,000 pieces, extremely evaluated, and put all back together, and everything works fabulously. Now, this is a very important issue. In a perfect world, all of our bug sweeps would be done in a 4,500 square foot garage. We would have hydraulic lifts. We'd have corner post lifts. We would have 8 mechanics in the garage, each specializing in a different part of the vehicle. And the garage would contain every known mechanical tool used by a mechanic or in aviation and equipment. It would be a sterile, clean room, white floors, epoxy floors. Everybody would be wearing lab coats so they didn't get any grease inside the car. Now, in a perfect world, that would be great. In reality, we have to work with what we have in the amount of time we're given, with the amount of supplies that we can bring, and we need to include in that cleaning supplies and a first aid kit, because we don't want to get blood all over the inside of the customer's car. If you can do more than a 4,500 square foot garage, or you can find a garage, for example, in Tribeca, there is an 85,000 square foot facility, and all they do there is they bring in luxury cars, and they store the luxury cars for a few days, and they do bug sweeps on the luxury cars. But this is also where they store the cars so that people can't tamper with them when they're in storage. So it's secure storage, and it works out quite well. And anytime a vehicle comes in to be parked there, they're all evaluated for any type of eavesdropping devices that it didn't leave with, and the cars are detailed and then stored until the client would like to check it out, and they'll send their driver over to get the vehicle, and it looks beautiful. It's stored indoors. There's no salt damage to it and no technical mischief. Now, these are some of the PCM scanners I mentioned earlier. The first ones that we can look at are the Auto Tap, the Acron, the B&B. These are generic one-size-fits-all mentality. They give you a great deal of data from a running engine, but they're not going to extract and explain aberrant codes. So for those, we want stuff like the Snap-on uh, or Mac Tools boxes, and we certainly need the dealership boxes. Now you can quickly spend, if you're a TSCM person, $45,000 on getting a Snap-on one, a Mac Tools one, a dealership one, and then one for 2 or 3 other vehicles that are specific for just that vehicle. Let's talk about Amish buggies. So I had an Amish uh, gentleman contacted me. He was a farmer and a stove maker. He knew that there were GPS trackers on his buggies and carts, and a voice recorder was suspected in his buggy because he did a lot of business on his buggy and not so much business in his office. We found 7 separate devices on his buggy, and in his workshop we found 6 different devices. And the person who had bugged him was the guy who was brokering the stoves that he'd made, and then that broker was a Mennonite who would then sell the stoves, and just beautiful stoves, to the English. Um, the Amish farmer was very displeased. This was 13 bugs, and they had been on his buggy and in his workshop for at least 3 years before he contacted me by mail, and we corresponded by mail, and he sent the money to pay for the sweep, and I showed up. I did the sweep. I was very thorough in what I did. I found everything, and I explained to him how to keep it from happening again, and great fun was had by all. Now, about a bugged Bugatti. An American purchases a Bugatti sports car, flies the same from Italy to Yale, where he is a student. Okay? Takes fellow law school students on drives to recruit them to join him in a complex drug and human trafficking smuggling scheme inside the Bugatti. I don't know what it is. Apparently, people who drive Bugattis like to get into things they shouldn't be. So, the Italian government bugged the Bugatti at the dealership in Italy and was spying on all meetings held in the car while he was in Connecticut and on the Yale campus, and they were tracking the car. The car's owner was tricked to visit Italy to get a free car, was arrested, and was extradited back to the United States to face charges, which is pretty foolish of him to be using his car as a private meeting area, because he didn't trust any place other than his car. But the Italian government had bugged his car right from the factory, and boy, oh boy, did this guy smarten up real quick. Let's talk about a bugged taxi cabs. Company has 32 taxi cabs and limos. They are new to the area, and competitors keep getting the jump on calls, which means they know where the other taxi cabs are, and are eavesdropping on all the dispatch frequencies by telephone and by over the radio. All the vehicles had GPS trackers installed on them by the competitors, and all the vehicles contained high-power audio transmitters so that everything that was said and heard inside the cab was being transmitted to a competing taxi company. Competitor was listening to conversations to jump calls to the other companies. I get brought in, I find the audio devices, I find the GPS devices. Instead of burning this other company, then suddenly false calls were gone out over their radio network, and their GPS trackers were placed on other vehicles to deceive, and ultimately the company that was the victim of the eavesdropping became the only taxi and limo company in that city because they had ground the other company completely out of business. So don't do crime. Now, some very common vehicle exploits is the cell phone. Those can be exploited from anywhere in the world. Your concierge services like OnStar, GM, Ford, Toyota, these are lethal to privacy. They have listen-in features. They were very popular in 3G, 4G. 4G's been a bit of a conversion, and then they're 5G now. These systems are very vulnerable as there's only a 12-bit security code, which means there's only 496 different keys, and it only takes a few seconds to figure out what your key is. There's also common vehicle exploits with garage door openers, which are rarely more than 8 bits, sometimes even as few as 4 bits, which gives us a very limited number of actual bits. For an 8-bit code, it's 256. For a 4-bit code, it's ridiculously less than that. There's similar conveniences like something to turn the lights on. There's also things like Speed Pass, RFID, and Fuel Club gas caps. Those all erode your vehicle privacy all over the world. Now, in practical terms, it takes a spy less than 30 seconds to install a bug or tracking device in your car. And in most cases, it can be done in less than 15 seconds. Less than 45 seconds is if he's slow and lame. But if you already have certain systems in your car, it only takes 5 seconds or less to readily exploit something that you already have. So if you have a dash cam, then it's less than 5 seconds to exploit that dash cam. If you don't have a dash cam, it'll take 15-20 seconds to install one. So let's continue. Our detection modalities are: first, we do an RF analysis. We look to see what signals are supposed to be on the airwaves on an unmodified vehicle. Then we use a variety of equipment we refer to it as tickle the sleeping dragon. So if there's a GPS tracker or an AirPod or some similar device, we want to tickle it and make it start beeping or chirping so we can identify where it is in or on the vehicle. And we want to make it wake up and make noise. We also are very obsessed about doing this. We want to do voltage and current analysis of everything in the vehicle, both when the device is not transmitting and then when the device is transmitting. And we want to see, is that being drawn from the radio? Is it being drawn from the PCM? Or is it being drawn from somewhere in the fuse panel? Because we have to monitor the entire fuse panel where we're doing this. And we're typically looking for something that's 3 milliamps of draw or more, or it could be a little bit less if the spy is extremely creative. For the physical inspection, this is quite manpower intensive. We have to have a clean lab, a large clean lab. We have to dismantle as much of the vehicle as possible and which is practical. This will include removing all of the seats, all of the upholstery, all of the rug, all of the jam hardware. We're going to take the doors off. We're going to take the radio out. We're going to take the dash out. we may very well end up having to take the battery out and the alternator out and some of the other items so that we can isolate everything and test it carefully. It's always limited by time, and if the client only has 6 hours, we're not going to jack the vehicle up. We're going to do it out on a tarp somewhere. Now, to do this, a full physical inspection requires a lab for 10 days, 724 in that lab, and there'll be 18 engineers working on 12-hour shifts, 36 engineers in total for 10 days. So that's 36. It's actually worked out to be 180 man days because we have some people working and some people sleeping, and we'll typically have 9 engineers per shift working on one aspect, and then 9 engineers working on the prior shift. So it's a considerable expense. It's a considerable manpower. It does take 180 man days. If it's a fancy, say a Rolls Royce or a Bugatti, it may very well take 250 to 360 man days in the garage to take this bad boy apart and evaluate it. So the more expensive your car is, the more expensive it's going to be to get this done. And there's just no simple way about it. Now, there's a few methods that are proprietary that our firm uses that other firms do not use. We utilize, for example, a GPS ping on GPS and cellular PCS bands. It is a device which will generate an illuminating signal and bombard something that will pick it up, and we look for a reflection of that signal, and then we look for a reflection on multiples of that signal. But this is computer controlled. It's very slow. We have to do it inside a double shielded enclosure, and it will make everything that is a communication device of any sort reveal itself, and reveal itself quite nicely. These are typically sweep generators with offset non-contiguous sweeps. They tend to be the most productive. And no, I'm not going to show you how to do one. So the reality of doing undercar inspections is it's highly messy. It's not something that's very pleasant to do, especially if it's 20 degrees below zero that day. It's going to be a lot of crawling around under the car. Even if you have a mechanic's hydraulic hoist, it's still going to be crawling around under the car. It's a less than optimal situation, and it takes hours and days, and it is really messy. The optimal process, which is how we prefer to do this, is we go out to the client site with a special shielded transport van. We move the vehicle into the transport van. Then we move the van to a specialty laboratory. The vehicle and the van are put into that laboratory, and then the vehicle is unloaded, dismantled, and inspected. The room must be double shielded, and it must be an exceptionally clean style of room or style of garage, and it is impossible to transmit any signal at all. It cannot detect GPS. It cannot send out a beacon of any sort, way, shape, or manner. Now, tracking devices are most often a GPS receiver and a cell phone transmitter. They could be part of an OnStar service. They're sold under a number of names and variants. There's also things like LoJack remote activation, and then there's security system elements, and then there's just straight up GPS trackers that just remember where a person goes. Silicon RF, which is state of the art, is making these devices smaller and smaller than your thumb, and shrinking. This is a typical OnStar surveillance module. You'll notice the dimensions of being just 2 inches wide and an inch and a half high. These are found in almost all GM vehicles, all Lexus. It's a simple module. It tracks GPS all the time. It provides engine telemetry and vehicle telemetry back to a monitoring station. There's audio surveillance capability with this, and it can actually control the engine and get engine telemetry. The item in question, it is sold as a CDMA system sold by Qualcomm. It's sold under the brand name of AnyData, OnStar, and GM. It interfaces to the vehicle electrical system. Its receive frequencies, actually the receive frequencies are not that important. The transmit frequencies is 824 to 848 megahertz, and then 1750 to 1778 megahertz, and then 1850 to 1905 megahertz. And that's the old DTSS systems. They are now on the higher band frequencies, and we can discuss those a little bit as well. These are some of the more advanced. Notice the sizes are 1.77 inches by 1.75 inches by only a fraction of an inch thick. They are very complicated, but these give whomever's interested full access to everything your car's doing, and these can even turn the engine off and slam the brakes on from anywhere in the world. These are factory installed. These are highly exploitable. These are a real joy to hack. These are hybrid devices, and the size is a danger to you and your privacy. The signal in question, as a rule, shows up very easily with a spectrum analyzer. You simply set a noise gate so that any signal that pops above that gate is documented and memorized, which is how this was caught. Just was set up at, let's see, the noise gate was set at minus 25 dBm, and it caught the signal very cleanly. It popped up for just a second, it caught it on the screen, then it was printed on the printer and rearmed itself to catch more of them, and we can then take this data and see what data it's sending. This is the location of the device in question. This is in the back of the vehicle. It just looks like an armrest, but this is what the little AnyData unit was hidden with. All you need is a screwdriver to get to it, but you got to know what to do with it when you do it. You'll notice on the right side that's a GPS antenna connection as well as cell phone antenna connection. This is a similar, smaller European version of that. This is what you're going to see in your Lamborghinis, your Mercedes-Benz. It's kind of cool with a Mercedes-Benz. You can walk into a car lot with a Mercedes-Benz and you can get them all to turn on and start honking their lights. You can get them to all open their doors, start the engines and everything, and you haven't touched any of them. It's an awesome thing to turn off, too, I might add. So, video surveillance is typically conducted inside where people have confidential discussions in their cars or in their limos. It's usually less important to know what's going on inside a vehicle, but it's more important to know what's being said. And it's very important to get people on video saying what's being said and not just have a wire that's doing a recording, because you have to pin the discussion or negotiation between the two people and how they're said and what their face body language is going. So it's most important to know where the vehicle is going, where it's been in the past, and understand that video is of less important to spies, but the audio is very important, and they always want the video to go with the audio. So they'll try to get video and tracking data first, and then on their second attempt, they'll try to install video so they get much more in-depth data from the car. This is from another one of my cases. The department had a problem with police dash cams. The police were sleeping in their cruisers, so the chief re-aimed the dash cams, and the officers did not know the chief did it. They were also having prostitutes get in the back of the cruiser with him, which they were not supposed to be doing. And the chief re-aimed these dash cams, caught his officers doing very naughty things. He suspended the 3 officers involved, and as a bonus round, the 3 officers got convicted and went to prison for, I think it was 6 years, for what they were doing. And that worked out to clean out a bad law enforcement agency. In a similar way, there was one group of parents of a 20-year-old put a dash cam in the car they loaned to him for her to go to college. It was just to record liability of accidents and things like that. After the daughter graduated from college, the original owners sold the same car to their neighbors, who assigned it to their 16-year-old daughter, who, a short time period later, got busy with her boyfriend in the car. The video got leaked. Teenager and parents were charged criminally due to the content of the video and the audio recordings of the girlfriend getting busy with his teenage boyfriend, like kids will do. The person who downloaded and circulated the explicit video was an 18-year-old student at the daughter's high school who had had a bad prior relationship with her. So, here's the facts. Old owners never removed it. It was an audio and video recording system. The old owners honestly forgot to remove. I would put in air quotes the word for honestly forgot. It was originally installed to supervise their one kid. However, after being sold, it caught a teenage couple being normal kids in the back of a car. The parents were prosecuted for bugging their children. The parents were also prosecuting for the creation of underaged erotic materials. This went to trial. The parents were found not guilty, and the teenagers were found not guilty. I think one of the teenagers actually ended up becoming a civil rights attorney because she learned quite a lot about what not to do in the back of a car. Another case is car rental companies put liability recorders to control their engines and track their renters. Now, they do this with high-risk renters, and sometimes their cars will just go dead because the dealership says they're dead. Customers tend not to be amused when this happens. They also record safety and speeding violations, and they fine the driver many times the cost of the speeding and many times the safety violation, or the driver will park in a place where there's a ticket issued to the car, and they'll fine the driver with that. It's kind of scummy what the rental cars do, but it's the way they do business. Another example is a suspicious spouse went to use her husband's car, and the phrase was, "That's not my brand of lipstick." That says much without saying too much. It's a very common situation. It was investigated to be marital infidelity. The results were divorce. The device was found too late, and it ended up being a multi-billion-dollar divorce just because a suspicious spouse found a brand of lipstick that was not hers. And billionaire divorces are really always really ugly things. So this is a typical GPS tracker that you've heard me talk about. These are passive trackers. They compute the location, they store the fixes and the locations. It's later retrieved by some mechanism. It can be retrieved by just retrieving the device and plugging in the computer, or it could have a radio link. These are very, very cheap, and there are millions of these sold per month. This is a bit more advanced. This is drop in and record, and it transmits over the cell phone channels, speed, altitude. It will even go into what speed they are. Are they 9 miles an hour, 75 miles an hour? What location they are, and then it'll put down maps as to where they were, where they stopped, where they pulled into, and so on. But this is state of the art. Slightly older state of the art, which I always found were quite amusing. This is an active GPS tracker. It has a very expensive cellular data link on it. It utilizes simple AT plus CTK commands. The default password, which most people don't change, is all zeros. And the default unit ID, which frequently doesn't get changed, is all zeros. Spies very rarely change the unit ID or the password, which makes my life highly amusing. Because knowing this, I will hook up to the serial port, and I will type in 2 commands. I'll do an AT plus CTKP with 000 and then blank 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 and then 000. So it knows that I'm sending it a signal, and then I send it information to make it scream itself to sleep. So like every 5 seconds it pops up on the airwaves maximum power, and it screams itself to sleep. And since it's doing over it a very expensive cell phone connection, it costs, when I make it scream, it costs whomever has the system set up thousands of dollars of excess bandwidth. So this sequence that I transmit is to make it start screaming. And you can max out the spy's account very quickly. You can easy to find it when you're having it scream with simple direction finding techniques. I use a phase coherent software defined radio system to do this. It works wonderfully. If I wish to do so, I can change the password, and then I can move this onto a semi truck that's heading up into Canada with, to get logs, and then make the max out the spy's account, and then suddenly it's showing up in the piney woods of northern Maine at logging camps, which will drive the spy absolutely crazy. This is a typical classified FBI spy tracker. I shall not speak of this too much, but this one is made in Canada. They make it in Canada so they can smuggle it in the United States and use it extensively without the use of search warrants. So I've got a whole video as to how the FBI does this and gets away with it. But this is what the signal looks like on the spectrum analyzer. It's nothing special, easily caught. And then this is your GPS tracker current draw, where you've got uh, 350 milliamps of draw for 4.5 seconds, and then it goes dead, and it does 1 milliamp of current draw for 2 to 3 minutes. This is the reason you want to check your milliamps on all your power connections. And then it goes, if the vehicle's not being moved, then it only draws 1 milliamp for 15 minutes to days. So we want to do stuff to make it talk a lot, and we want to grab where on the vehicle all this data, all this juice is being used up from. And we will find these, and we will package them up, we will disarm them, and we will provide them to a federal judge to figure out what to do with, which will outrage the FBI every time, guaranteed. Now, the audio risks, let's talk about the microphones. So it's easy enough to find the microphones. They're usually installed in the A-pillars, the headliners, the carpeting, and in the mirrors themselves. Tracking the microphone wires can be very laborious and time-consuming, especially if they've been put in after the fact. But there's no reason to put in microphones after the fact with modern automobiles, because there's so many spare microphones in there already that it's very easy to tie into. With the audio risks, consider that all speakers can be turned into a microphone, all speakers are an issue, and all of the speaker wires have to be very carefully and closely examined, and we have to be very suspicious of all dead speakers, because they might not be dead speakers, they may be very active microphones. Your audio risks are typically under your seats or inside the upholstery or in your A pillars and B pillars, in your visors and in your headliner. They may need to be manually retrieved by a spy. They may be wireless support for audio retrieval. So it might be a wireless device that needs access once a day to download the recorded audio. If you do have the wherewithal to hunt for these things, I always recommend looking for a 32.76 kilohertz clock signal, which is usually a very good way to find these, because they will almost always have a 32.78 kilohertz clock signal. And you're hunting for the master clock oscillator in the device, which might be 4 megahertz or 8 megahertz, but learn your devices and learn your harmonics, learn your oscillators, and you can very quickly make very short order of finding these. Now, these are usually a very quick plant device. They tend not to be overly buried, which means they're relatively easy to catch. Now, if you catch a device quickly, you need to assume that there's two more, because that quick device may be the one the spy wants you to find, and the other two devices are the ones he does not want you to find. So, when you find one, double down and let's go look for the other ones. Now, your biggest audio risks are typically going to be the old school, and it's based on your automobile belt line. Your old school bumper beepers had to be installed below the belt line of your car. The new school of thought is that with all the GPS and all the cell phones, they're installed above the belt line and very often in the roof, so they can hit cell phone towers. The transmitters with the right equipment is very easy to detect, and it's often the easiest spy is the easiest to catch. The laziest spy, is the easiest to catch. And this is an option for the laziest of spies, to install something above the belt line of your modern vehicle. This is a typical, very complex vehicle bugging system that is sold to the FBI and the DEA and Department of Homeland Security, and the FBI. Did I mention the FBI? They very rarely have search warrants when they install these. Uh, However, all of them have serial numbers and they all have DNA inside them, and they can all be tracked back to who made it, when it was made, who it was sold to, what the contracts are, etc. This is a devious little bugger, but there's thousands of these used by the FBI every year with absolutely no court order to do it. But that's just the country we live in. If you don't like it, change it. This is another bugging device. It's a little more crude unit, but it's only 2 inches by 4 inches. It works. It doesn't work well. But look at the crystal oscillator and the trimmer for it, and that tells us the easiest way to catch it. But this does work, but this is what we're looking for hidden up in the headliner. That particular, this next device, that's what it looks like on a spectrum analyzer, a 1600 to 1640 satellite uplink. This is an uplink to a satellite, and this is a truck telemetry system. Which is pretty cool. So we can see complex transmitter modules down here. In the midsection, we see the processors and the memory, and then we see the outlets for the to interface into the various systems of the truck. And then we see the connections up to the satellite communications system that's up on the roof of the truck. These are extremely widely used. There's basically no commercial truck or heavy farm equipment that's out that doesn't have this or a similar unit on it. Now, these are the little black boxes. There also do airbag controllers. There's accident recorders that remember everything. These little black boxes on commercial trucks, attorneys, police, and DOT love them. It says who did what, when, and why, and they may be interfaced to tracking systems, video systems, imaging systems, voice recorder systems, and so on. But they're fabulous units. Now, let's go back in time a little bit and look at some 1970s and 1980s era of what the DEA, the FBI, and private investigators were using in the 70s and 80s. This was an audio intelligence devices system. It was took a little bit of black magic to get to work and stay working, but it did work. It's called the AID Bird Dog system, and it worked at 150 megahertz. This is a similar system. You'll notice the very large magnets on the bottom. They would just go up to a car, turn it on, and then clamp those magnets underneath the gas tank and tip the antenna backwards. Again, this is 150 megahertz. Very easy to detect, even for the layman. All you needed to find this bad boy was a flashlight. 100% of the time, you could find these with a flashlight, a couple of little mirrors, a tarp, and some nitro gloves. Now these are a little more complicated. These are what we started to see in 2004. These are 2004 era bumper beepers. The range is miles. The batteries last hours to weeks. They do not use GPS at all. They instead ping, and they're attached with magnets. They're very low cost, and then you have to have a special folded dipole receiver to locate where they were. It operated in the 200 and 230 megahertz range. Then in 2005, this became quite popular. This was literally millions of these were sold to Department of Homeland Security and to Customs, and in a huge buy in 2005. It was a 215 megahertz law enforcement device. Note the size. It's 1.6 inch by 1.1 inch by 0.85. It's got a very strong magnet on one side. It is considered to be a throwaway disposable, and it would work for 9 to 10 days on a fresh battery. That should tell you a lot right there. You could also hardwire it into the vehicle and have the vehicle recharge the battery. Now, this is the future of bumper beepers. This is a 2006 bumper beeper. It is smaller than a quarter, an actual American quarter. Everything on this is super, super small. At the very top is the connector that goes out to the GPS receiver. So this is a GPS receiver that picks up, pulls apart the GPS, and then there's a phone circuit on this that transmits over the phone connector, which is also on a GPS shark fin, where this is. Now, keeping in mind this is smaller than a quarter, it's amazing where you can hide it. Now let's get into some things like low jack tracking. This, what you're looking at, is a low jack tracking system. It is at 173.075 megahertz. Its effective radiated power is approximately 200 to 300 milliwatts. So a police car with a low jack receiver in it can pick up a low jack signal about 1.5 miles to 2 miles away, so they can go to intercept it very quickly. But let's look what's inside of it. This is the chip that's on the printed circuit boards that are on the inside. There is a digital processing system. There is a chip to give it its receive and transmit frequencies. And the nice thing about this chip is it listens to the FM airwaves, and it listens for a subcarrier signal that sends a serial number of this unit to this low jack transmitter. When this low jack transmitter gets the right signal, it will activate. And this is the schematic for the this is the schematic for it. I had to work most of this out on my own, but you can actually see where the crystals are. You can see where the receiving is. You can see where the high power transmitter is, the universal control, how it works, how it uses the FM subcarriers. It's a fairly cool box. It's actually not made by LoJack. It's actually made by Motorola. When they are detected and in hunt mode, this is what the spectrum analyzer says the signal looks like. It's you'll see its center frequency is 173.075, and from a distance of 10 feet away, this is a pretty strong signal. But then we have time exclusion too, where every 16 seconds it goes into a hunt mode, and then it gives us a alert that here I am, and that allows the police to direction find on it. And then when it's parked and it goes to sleep, then it goes into a 1 hour sleep mode. So it's easiest to catch these things when they're in hunt mode and the car's just been stolen. Once they go to sleep, it becomes much more difficult to catch. But the police have had extremely good success with doing this. Now, one of the more things to be concerned about it's a very clever Apple product. It's called an AirTag. The battery can last a full year. It tunnels through other Apple products. It's Bluetooth oriented, it's very small, it's very versatile, and you can have a great deal of lawful fun with these things in how and where you place them. Uh, I know a lot of people, they put them in their cars, they put them in their briefcases, they put them in their expensive coat, they put them in their purse, they tape one to their laptop or in their laptop bag. So if any of that stuff takes missing, it's real easy to track down exactly where it is. Uh, it does quite a good job. So a few things to talk about before we wind this up is there's hazards and risks that we need to be familiar with of things that can harm you. We have to watch out for damaged wires caused by the spy. We have to look for battery loading, which makes the car not start, caused by the spy. We need to look for bad bulbs, which were caused by the spy. And we need to look for things that could potentially cause a vehicle fire caused by the spy. So we have to screen for all of those things and address them so that the car does not catch fire because the diodes were hooked up wrong in the bug. Now, when we do an observation of an automobile, before we really touch it, we want to observe some things. For example, we park it on a clean tarp, and we want to see if we have leaking fluids. Then we want to see if we have any bad things under the seats. So we put cameras and probes under the seats to see what kind of uh, difficult things we have under the seats. We look for missing jewelry that might be under a seat or between a seat or under a seat. We look for bad locks. So, for example, if the locks have been manipulated, we look to see if if the alarm's been bypassed. We look for missing grease and grime where there should be some. And this is typically because somebody has scraped an area under the car. We look for Velcro in odd places where it shouldn't be. And we look for adhesive tape residue where it shouldn't be. Now, when you use a TSCM specialist, they're going to have highly specialized skills. They're going to have laboratory grade test equipment. It's a long and tedious process. They will be performing hundreds of different test forms. It takes hours. A full exam is going to take at least 12 to 36 hours, ideally 72 hours with a group of 9 people on a shift. A cursory exam is going to be about 4 to 6 hours, though, and can just be one person. So TSCM stands for Technical Surveillance Countermeasures. It is an inspection by a technician or an engineer of a physical item or place. That engineer must be highly technically trained and must be highly technically trained in TSCM. There's vast equipment requires and vast equipment and tools required and very specialized protocol that is not used in any other industry. Now, some of the things that you can do to protect yourself without hiring a bug sweep guy is as follows. These are all freebies for you. First of all, install a vehicle security system, one that you can use to remote start your car. Consider removal of your OnStar system or concierge system, but understand that it provides a life safety function for you. Minimize your cell phone use in the car, minimize Bluetooth usage in the car, and buy a foil bag for your speed passes and only put your speed passes on your window when you know you're going to be traveling under a speed pass. Then take it out and put it in the Ziploc bag and stick it back on your seat. When you park, always lock your vehicle into an attached garage with smart locking doors. It does not mean you park your car in a garage and then walk across the street. It's got to be attached to your building. And all the doors into the garage and on the garage all need to be smart locking doors, and they all need to have cameras. Do not use wireless door openers when it's practical to do so. Um, I know it's not practical to have the little pedestals to type it in and read your fingerprint, but they do they do cause quite a huge problem with giving other people access to get into your garage door. Always park in a well lit garage or well lit lot that's covered by cameras. Watch for any scuffed interiors that suddenly appear. If it's your car and you're in it all the time, you'll notice scuffs all the time. Watch for missing screws or wires that are just hanging down for no apparent reason. And be wary of panels on a dash or on the doors suddenly being ajar. And as odd as this seems, pay attention to your seats being moved, because eavesdroppers very rarely put the seat back in the position it was when they started doing the bugging. And when your vehicles are in the shop for an oil change, supervise it. Don't leave it. There was a project I was on a few years ago, and I did my inspection, and I found 5 missing screws on a Porsche. Now, Porsche owners usually don't just have 5 missing screws. So I took apart the door cover for the A panel and then the headliner, and in there was installed an extremely elaborate audio, video, and tracking system that would not have shown itself with just the 5 screws. But I saw something was amiss. I started investigating it more. I got out my flashlight, my gloves. I inspected every square inch, but I especially inspected those inches, and a fairly elaborate eavesdropping system was pulled out of a Porsche. So if you're going to try to do an inspection on your own, use a flashlight and gloves. Inspect every square centimeter outside, especially around your bumpers, and pay attention around your lights and the underside. You also want to remove everything from the car. Don't have anything in the car that you don't absolutely need to have in the car. Remove your boot and your trunk liners. These are in the back of the trunk of the car. Remove your rear seats, remove your spare tires, and then start auditing all your wires and trace everything to everything. Now, when you're booking in a motor vehicle, so a customer has agreed to have you bring it in for a few days and tear into it, you need to know where the vehicle's normal location and normal garaging location is. You need to know the plate number and the VIN, the make and the model, the trim code, the engine size, the color, and what modifications they've done to it. You need to know the date of manufacture, and you need to try to get the service records or list of all prior work. If possible, you also need to get the type of audio video entertainment equipment they have on board. Is there Sirius XM? Is the OnStar active? Is a similar concierge service active? Is LoJack active or a similar system active? Then you do the vehicle tasking protocol, which typically gives you 475 pages of intensive checklists to go to. This analysis is usually manually intensive, but it's always based on what is in the shop manuals. And you take your shop manuals, you create your vehicle tasking protocol, and then everybody works off that until they work through the entire protocol, which is very time consuming and expensive. The search methodology is to do first standoff RF, which means you don't touch the vehicle. You look to see what it does in a double shielded room. And then you do an exterior search without getting in the vehicle. Look for things underneath. Then you go into the trunk and the liner and the tail lights. You inspect those. And then you very quickly get access into the interior, the engine compartment, the electrical tie-ins, the upholstery, the dash, the consoles, everything else, and then repeat and reverse everything. And then while we're doing all of this, we have to periodically stop and shake and tickle the vehicle, because some of these devices are only activated with motion of some sort. So we need to shake and tickle so we can get these devices to become talkative. Now, we have barely touched on how vehicles can be bugged. I'm not going to demonstrate how to bug your wife's car. I'm not going to go into how vehicle bugs are found, at least not yet. There are many, many other methods. You must pay very close attention to detail. Think about how you can find bugs before you think about hiring somebody to find bugs. But please don't break your car. And also, always assume that the vehicle's bugged until you can scientifically prove otherwise. Here's some of the important detection tools. This is a premium handheld digital voltmeter, and in the hands of an expert, they can make this an extremely valuable piece of equipment. This is a high bandwidth Fluke 199 oscilloscope. It does a fabulous job on tracing wires and looking for signals. It does have a great FFT spectrum analyzer mode, so you can use it as a spectrum analyzer as well. These are vector analyzers. These are vitally critical. They're basically a spectrum analyzers that's designed to tear apart and rebuild a cell phone signal of some sort. And these are extraordinarily valuable when we're looking for hidden cell phone transmitters. There's also some low-end broadband RF detectors, which I don't really recommend this model anymore. There's some higher quality stuff out there that you interface directly to chart recorders. And they really have to be, you really have to take them, hack them apart, and modify them to make them any reasonable level of effectiveness. You're also going to need some Marty Kaiser or Dektar or micro amp audio amps with DC bias circuits. These are to look for hidden microphones. You can also get some pretty sweet ones used in the professional audio business that will automatically bias the microphone, freeze the settings, If you get one of these, you're going to have to heavily modify it to make it even marginally useful. So go with some of the other stuff that works a lot better. Now, totally avoid spy shop toys. Use only laboratory grade test equipment and procedures. Take all the time you need. Never miss the details ever. And our cardinal rule is convenience and privacy are inversely proportional. I'll leave you with that. And I ask that you please keep in touch. You can easiest reach me at www.tscm.com. It's 65,000 pages of a world of information about TSCM. That's all free. Also on this channel, be it either Rumble or YouTube, please like the video, please subscribe to the video, and share the video with other people. Take care and have a very blessed day.